Hello guys, I am Nidhi S. Bagalwadi, your science teacher. In the last class, we learned regarding the refraction through the prism, dispersion through the prism. Today we are going to discuss regarding one more concept which happens in our nature and we enjoy it. So since nursery we are learning one poem, that is Twinkle Twinkle Little Star, how I wonder what you are. Okay, so this I think I forgot the poem. Okay, so this twinkling of stars is due to some phenomenon of the earth. So why the stars twinkle? Let us discuss. So we know that the stars will twinkle in the night. Okay, at the sky we can see them. But we should keep it in a mind that the stars which they appear for us, so will be quite nearer how they appear. Means we think the star is far, the star position will be different. It will be quite near than we look at them. So why it occurs? So we know that the refraction occurs when the medium of light changes, so that the speed of light changes in different medium, which causes the refraction. And we know the atmosphere is consisting of different layers, that is troposphere, mesosphere, thermosphere, as well as stratosphere. These are the four layers of atmosphere, right? So these four layers are less denser and denser than compared to the air. So when a light travels from rarer to denser medium, it should go undergo refraction. So that refraction phenomenon should be seen in nature. So that is nothing but the twinkling of the stars. So how it occurs, let us see. So let us consider this as a star. This is the first position of a star. Okay, this is the first position. This is the actual or real position of a star. From the star, a rays of light is incident. And here we know that it will be made up of a vacuum. The space is consisting of a vacuum. So in the vacuum, the speed of light will be same. So when a ray of light enters from the vacuum to different layers of atmosphere, we have different layers. So the layers of atmosphere becomes denser and denser. As we move, they become denser and denser. So the refraction occurs here. Finally, we will get the refracted ray to see. So when we proceed that refracted ray, we feel that the star is somewhere far from the actual position. So why it twinkles actually? So what happens? These layers of atmosphere are not fixed. These will be shaking, or we can call these will be moving from here and there. So due to their movement, the refracted light, the refracted ray will also be shifting from here to here. Sometimes it appears bright, sometimes it appears dim. So this bright, dim, bright, dim, bright, dim of that refracted ray makes or appears the stars to be twinkle. Okay, so this we can see by a best example. For example, just under your parent guidance, switch on the stove under your parents guidance only. Don't perform this activity alone. Okay, so switch on the stove. Okay, keep it in a high flame. Then take a torch, not from a mobile. Take a normal torch or a simple torch which you will get around 20 or 30 rupees in the market. So take a torch and keep it just away from the stove and observe the light in that flame above, just above that high flame. So you feel that the light is shaking. The light is not, it is flickering. Flickering means it is appearing dim, it is appearing bright, like that. So this flickering of light, why it is flickering? Because as we all know that, let us consider this as a fire. Okay, bonfire or campfire, what we enjoy when we go to the hotels or resorts or any trips. Okay, so this is a fire. We know that the hot air will be there above the fire. So the hot air will be less dense than the cold air. Surrounding cold air will be there. Okay, so here we have hot air. So this hot air is less dense than the cold air. So the refraction of light occurs in several ways here in the hot air also. When it reaches the cold air, it will be different. The refraction will be different. So this, as the hot air vapors are there, no, hot air, this is not same, like this will not be here. This will be moving here and there. So this movement of the hot air makes us feel us to make that the light is flickering or the light is shaking. So this experiment you can perform at your home using the stove under your parents' guidance only. So it appears, the light appears flickering or shaking. Okay, it is due to this phenomena, that is atmospheric refraction, the refraction which occurs through the Earth's surface. So this is the reason behind the twinkling of the stars also. Now, let us consider the sunrise or the sunset. So we all enjoy the sunrise as well as sunset, usually the sunset at the beaches, right? So the sunrise, even though let us consider the sun rises at 6:30 a.m. You can see the sunrise at 6:28 a.m. Means you can see the sun at 6:28 a.m. only. 2 minutes before. 2 minutes before even the sun is actually on the earth. Even before that we can see the sun. How? So here we should remember one more concept or one more term, that is a horizon. So what is this horizon? Horizon is an imaginary line which appears, which makes us to feel that earth is meeting the sky somewhere. So that boundary is there, no, that imaginary line. So if you go there, you know it will not meet. You can find one more horizon. So it is nothing but it is an imaginary boundary where it appears like sky is meeting the earth. So let us take this as a horizon, the dotted line. And during the sunrise, what happens? This is a sunrise time. Let us take this as a sunrise. Okay. So during the sunrise, the sun is below the horizon. Below the horizon means we are not able to see the sun actually. But what happens here? A light from the sun, okay, is incident through the atmosphere. We know that atmosphere has several layers, denser and rarer mediums. So due to the multiple refraction, not only one refraction, many refraction through the layers of the atmosphere, we will get a refracted light. So we are standing on the earth. Let us consider we are standing on the earth. So this is a refracted ray of light. When I proceed the refracted ray of light, the image of a sun is formed here. So before the sunrise only, I am seeing the sun. This is due to the atmospheric refraction. Next, let us consider a sunset. So sunset in the west side. Okay. So this is the sunset. So here I think it is not visible. So this is a sun which is already got set under the horizon. So what happens here? The light from the sun travels in the atmosphere, layers of atmosphere, undergo multiple refraction, many times refraction, and the refracted rays will meet and form an image of a sun which we are able to see even after the sunset. So this image is not permanent. We are not able to see after complete sunset after 1 or 2 hours. We are able to see the sun after sunset only after 2 or maximum 5 minutes. After that we will get to know the sun has set. So this due to the multiple refraction from the sunlight rays which is occurring in the atmosphere, okay, it is also a reason for a sunset, vision of a sunset even after the 2 minutes of the sunset, and sunrise also. Even before 2 minutes of a sunrise, we are able to see the sun. That is due to the atmospheric refraction. Okay. So this is how the atmospheric refraction, we are able to see the examples in the nature, that is twinkling of stars. 2 minutes before sunrise, 2 minutes after sunset, we are able to see the sun. This is the concept of atmospheric refraction. In the upcoming sessions, we are going to learn one more concept about scattering of light, and we are going to in detail in that concept. Right? Until that, take care of your eyes. Have a nice day.